One final change we make in this computation is that we're only interested in features that have a positive influence on the score for cardiomegaly. So here, just expanding out the localization map so we can see all of the numbers, we'll set the negative numbers here in the localization map to 0. And the positive numbers we keep as they are. And this is applying the ReLU function, which all it's doing is deciding which is greater, the element or 0, and setting it to the max of that. So we make that modification to the computation of the localization map L. Now, rather than look at the localization map as numbers on a table, we can visualize it using a heat map. A heat map is generated using a color map that translates numbers into color. In this case, the more positive numbers are going to appear bright, and the numbers close to 0 appear black. The heat map is generated at a low resolution because it's the same size as the spatial map, which we saw earlier was 10 by 10. We usually have to resize it and usually have some kind of interpolation to fill in the gaps when we resize to bring it up to the size of the X-ray image. Finally, we can now overlay the resized heat map on the original image. Sometimes transparency is added to the heat map, sometimes proportional to the score for the class, such that the heat map is brighter when the score is higher and less otherwise. When we combine the two, the heat map and the X-ray image, we get this overlay which shows us where the model is looking to make a particular decision for cardiomegaly in this case. And thus we can compute the GradCam for cardiomegaly using this procedure on even new images. As a final extension, if the model has multiple possible output classes, as your model for chest X-ray classification does, there is a different heat map you would want per disease. This is because different parts of the image are going to be indicative of different for that class, YC, to get weights for that particular class, small ac, which in turn produces class-specific heat maps. Here we have the heat map shown for cardiomegaly and edema, both of which are present in this image. And so this covers the GradCam method for visualizing our deep networks. Congratulations on completing the third and final course for the specialization. You have now covered the third branch of medicine, treatment. You learned about tools for causal inference, where we only observe what happens to a patient if they got a treatment or not, but what we really care about was the difference in outcome when the patient gets the treatment versus when they don't. You also learned about tools for extracting information from applications of medical question answering and label extraction from text. In Course 1, you covered deep learning tools for medical image interpretation, and in Course 2, you covered machine learning tools for working with structured data, including survival modeling. In Course 3, you finally learned about methods to interpret these models that you built in those courses. Congratulations once again on